Many homeowners have reset tripped circuit breakers, possibly even replaced a few of them, but do you actually know how the circuit breaker is designed to work? Well, I removed my cover so you don't have to. Stay tuned because we're going to go over all the insides and how it works. Okay, as far as the internal components, we have, of course, the circuit path, as you can see. Of course, this is the switch. This is the mechanical piece that you move back and forth when you reset or turn on your circuit breaker. You have your non-moving terminal here. This is the one that actually hooks into the bus bar inside your circuit panel. It's getting its power from your main feed. So this is the input terminal into the circuit breaker. This here is the moving contact, and I'll show you in a minute why it's a moving contact, but it flows through this moving contact through this circuit over here. Here is the thermocouple. This is actually what heats up when you have an overload condition. This thermocouple heats up and it will actually trip the moving pieces in here, and I'll show you that in a second. And then you have, of course, your terminal screw here. This is where your circuit wire goes out to your circuit. So essentially power comes in through the non-moving terminal, through the moving arm, through this part, over to the thermocouple, around over to your terminal screw and out to your circuit. This clip here, as you can see, is not actually hooked to anything in the circuit. It just helps hold it onto the circuit breaker panel. You have your orange flag. It basically moves this orange flag into that clear window so you can easily see when it has been tripped. Now we'll do a quick demonstration. I've set up my meter in series with this. I've got it in the continuity setting, so we'll go ahead and turn that on. You can hear that the circuit is being made when you have an heat up condition. This thermocouple is going to move over and trips. Now, if you notice, the moving lever there inside has broken away from the non-moving terminal, and this is actually what interrupts your circuit right here. Okay, we've gone ahead and reset it, and remember, what's happening is the circuit's heating up and this thermocouple right here is expanding, and when that expands, it will trip and move this contact arm over. Let's go ahead and watch it in slow motion now. Okay, now I'll show you quickly how to troubleshoot this circuit breaker, and it's actually convenient to be able to see what's going on the inside. So if you have a circuit breaker that's not working correctly, this may help you in troubleshooting, determining if your circuit breaker is actually bad or if there may be something else in your circuit that needs attention. Now, we've still got our meter hooked up in the ohms position. We've got our red lead on our circuit output, and of course our black lead on the bus bar contact side of it. Right now it's still in the trip position. You can see the orange in the window there, and you can also see the moving contact has separated from the terminal, thus interrupting the circuit. So right now in a normal condition, you're going to have OL, and you should no longer have continuity or the tone. And I've reset the circuit breaker. You can see now that it is in the on normal condition. You no longer have the orange flag in the window, so everything seems to be operating normal with the circuit breaker. You can also tell that the moving contact arm there is now making connection with the non-moving terminal. So our circuit is being made through the circuit breaker, and you can verify that with the 0.1 ohms or with the continuity tone. So the circuit breaker is working as it normally should right now in the on condition. As you can see, there are a lot of parts inside the moving circuit breaker, and this can cause issues when you think you have a good circuit breaker. It looks good from the outside, but you can't usually see all these internal pieces, so anything in there that breaks or is bent or is manufactured incorrectly could cause issues where you think you have a good breaker, but there's actually something defective in there. So in this case, it appears that the contact is making a connection here. It should be running through the circuit breaker out to our load, but as you can see, we have an overload and we have no tone, no continuity. So right now it appears that we should have continuity and flow through our circuit breaker in that on condition, but again, we do not. So we have an issue here, and that could be any of these parts. The movement arm could be a little bent. It could have tripped and dislodged. There's a spring right there. Sometimes that spring can pop off. Anything could be preventing that contact from being made right there. If this is the case, then there's nothing really repairable, because to remove the cover, you really have to drill, so you're not going to be able to fix it. At that point, I would bring the old one with you to the store and replace that circuit breaker out. Let's say that your circuit breaker has overloaded and tripped And you can see that the moving contact is actually not in contact anymore. So the circuit breaker has tripped, but as you can hear and see, we are still getting continuity across the circuit breaker somehow. So what that means is somewhere internally inside that circuit breaker, you've got another connection that's an inadvertent connection. Even though it's tripped in the off position, you have your orange flag, it's still making continuity. Now this is probably the most dangerous situation, because if this happens, which is fairly rare, but if it were to happen, your circuit breaker is no longer working in the circuit, and if something did trip that circuit breaker, it means something is overloaded, overheating, and it could cause a fire in your house. So if you have this condition, you need to immediately remove all your main power to your circuit breaker panel and get the circuit breaker out of there. The most likely component that goes bad inside the circuit breaker is the thermocouple itself. A lot of times over the years, the wear and tear on these has weakened the thermocouple, or it's just come with a defective one. So if you've already checked all the components in your circuit and you're fairly certain that those aren't overloading, but your circuit breaker is still tripping, it may be time to replace it. Hopefully now you better understand how the internals of the circuit breaker does work. This should help you in troubleshooting. If you found value in this video, please help us out. Subscribe to the channel here and watch our next video here.